Over $20 billion. That is the value generated by the quartz manufacturing industry, a material considered almost immortal on Earth. Behind that enormous figure lies a chain of sophisticated technologies where tiny grains of silica are reborn into engineered slabs that combine strength, brilliance, and timeless beauty. From crushing natural quartz and blending it with polymer resin, to compressing it under hundreds of tons of pressure and polishing the surface until it reflects like a mirror, every stage demands remarkable precision and control. In today's video, join the factor-in as we step inside one of the largest quartz factories in the United States to uncover the meticulous process behind this extraordinary material. Quartz Slabs Overview. The global quartz market has been growing at more than 8% annually, making it one of the fastest expanding material industries of the past decade. This surge is largely driven by the demand from the high-end interior sector, as over 70% of the world's engineered quartz production is used to craft kitchen countertops, bar surfaces, and wall panels in modern residential and hospitality projects. In the United States, growth has accelerated even further after the government imposed anti-dumping duties on quartz surface products imported from China. This decision spurred domestic brands such as Cambria, Caesarstone, and Elite Quartz to expand their production lines, turning the U.S. into a new hub of the global quartz industry. But do you think this really helps protect American jobs, or just makes quartz more expensive for no reason? Raw material extraction. The journey of quartz slabs begins at open-pit mines, where the terrain is carved into massive step terraces. Geological engineers use mineral maps and topographic data to pinpoint areas with the highest quartz concentration. Once the site is approved, drilling rigs and heavy excavators move in, cutting through the rock face and gathering large chunks of quartz into piles. Gigantic haul trucks, each weighing dozens of tons, transport the raw stone to the crushing station. Inside the control cabin, monitoring systems display real-time data on load weight, location, and output, ensuring every trip runs efficiently. At the first processing stage, the quartz rock is coarsely crushed, screened, and fed onto conveyor belts. The white stone begins to break apart into smaller fragments, then continues through secondary crushers until the particles reach just a few millimeters in size. By the end of the extraction phase, the once solid mountain quartz has transformed into a stream of bright, refined crystals, ready to enter the next stage of industrial production. Quartz slabs manufacturing process. After being crushed and sorted by size, tons of raw quartz are transported to the mixing area. Here, each batch of material is poured directly into a massive industrial mixer lined with wear-resistant steel. An automated dosing system precisely controls the ratio of large, medium, and fine particles to ensure the final slab structure remains solid while maintaining a smooth aesthetic finish. Once the quartz is ready, a special polyester resin is pumped into the mixer. Unlike ordinary plastics or fiberglass resin, this formulation offers exceptional bonding strength and high heat resistance. When cured, it forms a durable polymer framework that tightly encapsulates each quartz grain. This layer gives the slab its resistance to water, impact, and color fading over years of use. The mixing process takes place in a sealed environment where temperature and humidity are carefully regulated. Inside, the paddles rotate at high speed, allowing the resin to coat every grain evenly, while a vacuum system removes any trapped air or bubbles. This step is critical. Even the smallest air pocket could cause voids or cracks during the later compression stage. Depending on the desired look, pigments, glass chips, or metallic pigments can be added at this stage to create natural veins and reflective effects. Engineers monitor viscosity, uniformity, and temperature through the control panel in real time. Once the mixture reaches the ideal wet state, meaning all quartz particles are fully coated and no dry surfaces remain, the system automatically stops and discharges the blend onto the conveyor, ready for the next forming phase. Once the quartz and resin mixture is fully blended, it is transferred to the spreading station, where the slab begins to take shape. Before spreading starts, a polyethylene film is carefully laid over the steel mold surface. This film prevents the mixture from sticking, allows the slab to separate easily after pressing, and ensures the surface remains smooth and perfectly clean. When the film is in place and completely flat, the quartz resin mixture is released onto the industrial vibrating conveyor under an automated dosing system. The material is continuously distributed through feed hoppers, forming a uniform layer across the entire mold. Above it, mechanical leveling bars move rhythmically back and forth, spreading the material evenly and controlling the material thickness at every point. Integrated laser sensors and electronic scales adjust the feed rate in real time, keeping the slab's thickness variation within just a few hundredths of an inch, a level of precision nearly impossible to achieve by hand. In smaller workshops, however, this step is still performed manually. Workers use metal trowels or scrapers to spread the mix, gauging the texture and adjusting the direction to create natural-looking patterns. For premium collections, skilled artisans may sprinkle mirror chips, glass fragments, or metallic pigments onto the surface, adding depth and a unique reflective effect to each slab. Once spreading is complete, a light vibration and preliminary vacuum process is activated to remove trapped air and compact the material slightly. Then, laser scanners sweep across the surface to verify flatness, ensuring every slab meets the required standard before moving on to the vacuum vibro-compression stage, where pressure and vibration will transform this loose layer into a dense, solid quartz slab. After the quartz resin mixture is evenly spread, the semi-finished slab moves to the industrial veining station, where the distinctive patterns of each product line are engraved with high-precision technology. A massive CNC machine, equipped with automated nozzles and carving heads, begins its operation. Guided by pre-programmed software, the nozzle moves rhythmically across the surface, simultaneously etching fine grooves into the wet mixture, while injecting pigment or mineral-based coloring compounds into those freshly carved lines. The result is a series of flowing veins with natural depth and gradient, closely resembling real stone. For more intricate designs, the machine performs multiple passes of carving and pigment layering, building complex multi-tonal effects that replicate the cross-section structure of genuine marble. Each pattern is stored as a unique vein code, allowing manufacturers to reproduce it thousands of times with micron-level accuracy. However, in high-end or custom collections, human craftsmanship still plays a vital role. Skilled artisans use small metal tools to drag, blend, or feather the pigments by hand, introducing subtle gradients and organic irregularities that machines can't fully emulate. The balance between automation and artistry ensures that every slab maintains its industrial consistency, while still carrying a touch of natural imperfection, the hallmark of authentic quartz stone design. Once the veining process is complete, the semi-finished quartz slab is transferred to the vacuum vibro-compression area. Before pressing, workers or the automated system carefully lay a thin polyethylene film across the entire veined surface. This film not only protects the slab from dust and contaminants, but also prevents the polyester resin from sticking to the mold, allowing the slab to be released easily after compression. At the same time, it helps define the initial smoothness and gloss of the slab's surface, reducing the amount of polishing required later. Once the film is perfectly flat and secured, the mold is placed inside the sealed compression chamber. Inside, high-powered vacuum pumps remove all air, eliminating even the tiniest bubbles and microvoids that may remain in the mixture. When the chamber reaches the ideal negative pressure, the massive hydraulic press lowers the mold, applying several thousand psi of force. Simultaneously, the press bed vibrates at high frequency, causing the quartz particles and polyester resin to move, settle, and bond tightly together, filling every microscopic gap to create a perfectly uniform and densely compacted structure. Throughout the process, an array of temperature, pressure, and vibration sensors continuously monitor and adjust parameters to maintain stable conditions. In just a few minutes, the raw, wet mixture is completely transformed from a soft, loose compound into a solid, seamless, and highly durable quartz slab, perfectly flat and ready for the next phase of curing and hardening. After leaving the press chamber, the quartz slab is still in a semi-stable state. The resin inside has not yet fully hardened, and the polymer bonds are still forming. To complete its structure, the slab enters the curing and hardening phase. In this stage, each slab is placed inside a specialized drying oven or thermal chamber, where the temperature is maintained between 200 and 250 degrees Fahrenheit over the course of several hours. The heat activates the polymerization of the polyester resin, causing its molecular chains to permanently bond with the quartz particles. This reaction creates a dense, thermally stable network that gives the slab its strength and durability. Hot air circulates continuously within the chamber, while fans and filters keep the environment clean and dry, preventing any dust or impurities from adhering to the surface. Once the required temperature and duration are reached, the slabs are gradually cooled inside a sealed chamber to avoid thermal shock, allowing the material to stabilize completely. By the end of this phase, the quartz slab has transformed into a seamless, high-density material with exceptional hardness, a perfectly flat surface, and an internally compact structure, ready for the next stages of mechanical, finishing, and surface refinement. When the curing process is complete, the quartz slabs are transferred to the edge trimming and grinding area to remove excess material around the perimeter. During pressing, some resin and quartz tend to overflow from the mold, forming rough edges or slight ridges along the sides. In large-scale factories, automated cutting machines equipped with diamond-tipped saw blades trim each slab to its precise dimensions, typically with a tolerance of less than 1/16 of an inch. However, not every detail can be perfected by machinery. After the automated cutting, skilled workers use handheld grinders to refine the edges that remain sharp or uneven. With diamond polishing discs, they carefully run along each side, checking flatness while removing tiny burrs and imperfections invisible to the naked eye. After being cut and trimmed, the quartz slabs move on to the calibration and polishing stage. Here, each slab passes through an automated grinding line, equipped with multiple diamond-tipped polishing heads. At first, coarse diamond discs remove any excess material, bringing the slab to the exact standard thickness. Once the thickness is perfectly adjusted, a multi-step polishing process begins, using progressively finer discs. The surface is gradually refined until it becomes smooth and mirror-like. Some slabs are polished to a high gloss finish for strong reflection, while others are left with a softer matte look depending on the design. Throughout the process, cooling water is sprayed continuously to reduce heat and wash away dust, keeping the surface perfectly clean. The result is a flat, shiny, and visually flawless quartz slab, fully prepared for the final inspection and packaging stages. Inspection and packaging process. Before packaging, each quartz slab must undergo a strict quality inspection process. Here, technicians perform checks using both automated equipment and manual observation. A system of laser scanners and high-resolution cameras scans the entire surface to detect even the smallest imperfections. At the same time, workers inspect each slab by hand and sight, gently running their palms across the surface to feel its flatness, gloss, and smoothness. Any slab showing scratches, discoloration, or irregular veining is immediately set aside for repair or recycling. Only when a slab passes all quality standards is it labeled as approved and sent to the protective film application area before packaging. This stage ensures that every slab leaving the factory meets the highest standards of quality, not only visually flawless, but also durable, stable, and long-lasting for years of use. After passing inspection, the quartz slabs are moved to the packaging and palletizing area, the final stage before shipping. Here, workers apply a protective film over the surface of each slab to prevent scratches during transportation. This film is lightly adhesive, transparent, and can be easily removed once the product reaches the customer. Next, each slab is carefully placed onto metal racks or wooden frames, lined with rubber padding to hold them securely and absorb vibration. The slabs are arranged vertically with even spacing to prevent contact and chipping. Overhead cranes or forklifts then transfer the loaded racks to the palletizing zone, where they are tightened with steel straps and wrapped in shrink film to ensure maximum stability and protection throughout transit. The packaging stage not only safeguards the slabs from potential damage, but also serves as the final assurance of quality, guaranteeing that every quartz slab leaves the factory in flawless condition, ready for its journey to customers around the world. Conclusion: from raw stones mined deep in the mountains to the polished quartz slabs that shine in modern kitchens, this journey stands as proof of the power of technology, the precision of craftsmanship, and the passion for creating the perfect material. Every stage, from crushing and mixing to pressing and polishing, reflects a seamless blend of engineering and artistry. If you enjoyed this exploration, don't forget to hit the like, leave a comment to share your thoughts, and subscribe to our channel to discover more incredible stories from the world of manufacturing.